Hey Panthers, we are back with the second day of direct variation, and yesterday we spent some time looking at x and y values and deciding if there was a constant k value which represents our unit rate, and then we wrote the equation y equals kx. Today we also looked at graphs yesterday. We looked for graphs that formed a straight line that went through the origin. Today we are going to look at some story problems. So what I want to start with today is just to kind of bring this all together, because I know we've been talking about these things separately, and I want to just show you real quickly all of this stuff that we've been doing, the y equals kx equation. We've done the tables of our x and y values. We've talked about ordered pairs. And then most recently, we've actually looked at graphs. So let's go back and look at this particular equation, y equals 3 times x. In other words, this means that every y value is 3 times greater than the x values. So let's plug in some numbers. Let's plug in for x. Let's say x was 1. Remember the input-output tables. If I plugged 1 in for x, 3 times 1 would be 3, so y would be 3. If I plugged in 2 for x, so x is 2, 2 times 3, y would be 6. If I plugged in 3 for x, I'd do 3 times 3, which y would then be 9. And we end up with some ordered pairs here. I'm going to write them out. Okay, remember x comes before y here with our ordered pairs. So if we've looked at the equation, we've looked at the tables of x and y values, and then yesterday we looked at some graphs. So I'm going to show you what happens when I graph these ordered pairs. Now Panthers, please understand that I hand drew this graph and it is not exact. So let's go ahead and graph this. Remember, you always start at the origin, and the x value tells you to go over 1 and up 3. So up 1, 2, 3. And I'm going to put a point here, and I'm going to label this 1, 3. Our second ordered pair is 2, 6. Panthers, count over 2 and up 6. 1, 2, 3, 4, 5, 6. We're going to put a dot there, and we're going to label this 2, 6. And our last ordered pair is 3, 9. So go to the over 3, so 1, 2, 3, and this time we're going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just going to kind of estimate here. What do you notice about these 3 dots? Hopefully you notice that when I connect them, they form a straight line that goes through the origin. And this kind of wraps up everything that we have been talking about. So let's go back to your notes. This is the second part of direct variation. This is day 2, and let's take a look at these examples. This first example states that the cost of online music varies directly with the number of songs bought. Suppose 7 songs cost $9.03. Step 1, we're going to write an equation. Remember our equation, y equals k times x. We're going to write an equation that can be used to find the cost of x songs. Okay, remember our k value, we can find that by doing y over x. So let's start remembering our k value is found by doing y over x. Here our rate is given 7 songs for $9.03. Remember, money is always on top. So for $9.03, we're going to be able to purchase 7 songs. So here's the rate that is given to us. Now we can use this rate to then find the unit rate which remember is our K value, and use that to create the equation. So remember, you take your top value or your Y value and divide it by your X value. So grab your calculators, Panthers, and let's solve. $9.03 divided by 7, you'll find that it is $1.29 per song. Now please remember, we are trying to write an equation, and we can use this unit rate and plug it back into our K value and get the equation y equals 1.29x. This equation can be used to find the price for any number of songs that you would want to buy, not just 7, or you could also use it to figure out if you had a certain amount of money you could spend, how many songs you could afford, or again, how many songs, if you bought a certain number of songs, you could use this equation to predict what the cost would be. So step 2, let's find the cost of not 7 songs, but let's find the cost of 18 songs using our equation. Remember, we know that y is the cost. So the cost is $1.29 multiplied by x, which x, remember, represents the number of songs. So if we're finding the cost of 18 songs, Panthers, remember that songs represents our x value. So I'm going to take 18 and plug it in for my x value. Let's recopy this. Y is going to be $1.29, but instead of multiplied by x, we're actually going to purchase 18 songs. Grab your calculators, type in $1.29 times 18, and you're going to find out that y is $23.22. Again, it is important to put your dollar sign as it recognizes the type of units that we are using. That is example 1. Let's take a look at example 2. Example 2 is the cost of gasoline, and it directly varies with the number of gallons bought. Okay, in other words, if you buy 1 gallon of gas, you'll have the unit price, and that price can be used to find any number of gallons of gas that you want to purchase. And again, when we see this term varies directly, also kind of talking about proportionality. Okay, so let's take a look at step 1. We're going to write an equation that could be used to find the cost of X gallons of gasoline. Reminding you again that K value is what we need to solve our equation. To solve K, remember we do Y over X, remembering that Y always represents money. So if we take a look at our original problem, we have the rate 3 gallons of gas for $11.94. In other words, it's $11.94 for 3 gallons of gas. Now this is not what we're trying to solve here. Again, we're trying to come up with an equation. Remembering our equation is the y equals your k value times x. This does not represent our k value yet because we need to find the unit rate. So take that top number, $11.94, divided by the bottom number, which is 3. Grab your calculators, Panthers. You're going to find out that your unit rate is $3.98. So let's fill this k value into our equation. The equation we can use to find out the cost for any number of gallons is y equals 3.98 times x. Using this equation, we can now solve part 2. Find the cost of 21 gallons. Panthers, remind yourself gallons is representative by the x variable. So let's rewrite our equation. And this time our x value is going to be 21. So the cost is going to be equal to 3.98 multiplied by 21. Grab your calculator. Our cost again, remember y represents cost, is going to be $83.58. Okay, good. Let's move on. Now example 3. As it is being dug, the depth of a wide hole for a backyard pond is recorded in the table. So we're looking back at tables here, Panthers. So we have some information. I want to remind yourself that here we're looking at time. Remember, time is always the x variable, so we'll label this y. We're asked here initially, does a direct variation exist within this table? Well, let's take our y values and divide it by our x. The first one, we have 8 divided by 10, which would simplify to 4 to 5. We have 16 divided by 20, again, is 4 to 5. 24 divided by 30 is 4 to 5. And 32 divided by 40 is also 4 to 5. Panthers, do we have a constant rate here? We certainly do. So our answer is yes. The k values are the same. Okay. And part B, let's go ahead and write an equation that relates the time and the hole depth. So again, to write our equation, we must know our k value. In this case, y, you can just pick any of these. Let's pick 8 for the first ratio, compared to x, which is 10. If I simplify this, we get 4 to 5. And some of you also could get the decimal 8/10. Okay, I'm going to go ahead and use 8/10 for this particular one. So to write an equation, I am just going to write y equals my k value, or my unit rate, is 8/10 times x. Using this equation, I can predict how long it will take to reach a depth of 32 inches. Go back and look at our original k values. Which variable represents inches? Is it y or x? If you look up in your table, y was represented with the inches. So this time, if I have my equation, y equals 8/10 x, this time we're going to plug in 36 for y. And you have your one-step equation here. To get x alone, you divide both sides by 8/10, and you find that x is equal to 45, and the variables for x is minutes. Okay. And this last one, Panthers, I'm going to move a little bit faster. The graph shows the cost of apples. Does a direct variation exist? Remember, Panthers, you must have a straight line. Does it go through the origin? Yes. There's a straight line through the origin. Okay. B, write an equation. To write the equation, all you have to do is pick up one of these ordered pairs. So I have the ordered pair 1 and 25/100, which is the x value, and 1 is the y value, and I can use this to write my y over x, which in this case is 1 over 1 and 25/100. If I were to divide that out, guess what, Panthers? We get the exact same k value. So we would have y equals k, which is 8/10 times x, and then you can use this to figure out how many pounds these apples would cost. Panthers, go ahead and finish this, but before you leave, I have a quick joke for you. What occurs once in every minute, twice in every moment, and yet never in 1,000 years? Panthers, have a good day. Remember, I will see you on Monday.